These notes are on solving a system of linear equations using a process called elimination. And these go with the task 5.9. In elimination, you will use a process that allows you to cancel or eliminate a variable in a system of equations in order to solve the system. So we'll look at a first example here, and then there'll be more examples in subsequent videos. This first example is to solve 3x minus 3y equals 10 and 2x plus 3y equals 5. So in the previous task, 5.8, you experimented with working with scenarios in which you did this elimination, but you did it for very concrete examples, bags of dog and cat food and other items. So in this example, we're getting away from the context of the dogs and the cats and their food and various things, and instead we're going to go straight just for the variables. So when I look at this problem, though, it is set up kind of nicely. And it's set up first that both equations are in standard form. ax plus by equals c. ax plus by equals c. The second really nice thing about the way this equation is set up is that I actually have a variable and a coefficient in one equation and in the other equation that are the same except their signs are different, which means I can automatically take my two equations, and before I do anything else, I'm going to label my equations A and B. I can automatically take my two equations and add them as they stand. So 3x minus 3y equals 10 plus 2x plus 3y equals 5. And I'm adding these just like you learned to add facts, addition facts back in elementary school. So 3x plus 2x is 5x. Negative 3y plus 3y is 0, so it goes away, it cancels. And I'm left with equals 10 plus 5, which is 15. I'm now in a position where I can solve for x. I've eliminated, canceled the y values by having them be the same coefficient but different signs. And so now I can finish solving for x. Divide both sides by 5, and I get x equals 3. Now remember, just like in previous notes where we talking about solving systems with substitution, what I'm actually dealing with here are two lines, and I'm trying to find the place where the two lines intersect or meet, and that happens at a point. Points have an x value and a y value. So far I have found my x value, so I now need to find my y value. And I'm going to do that by plugging in x equals 3 either into the first equation, equation A, or the second, equation B. So I'm going to plug x equals 3 into A. Doesn't matter which one you use, we should both get the same answer regardless. And I just use this notation to kind of outline what it is that I'm doing so that I can always go back and look at my work, or someone else can read my work more easily. So the A equation is 3 times 3 minus 3y equals 10. That's 9 minus 3y equals 10. I subtract 9 on both sides so that I can solve for y. It gets me negative 3y equals 1. I divide both sides by negative 3 so that I can isolate the y. I get y equals negative 1/3. Remember, division is the same as having a fraction bar, and because negative 3 can't go into 1 evenly, I just leave it as a fraction. And then my final step is to write my answer as a point, because that is what it is I'm trying to solve for.